Good morning, everyone. I'm very happy to have this opportunity to give a present today. And the article I want to share is Standing Stock and Mass Balance of Marine Litter in the Seto Inland Sea, Japan. And the ocean currents and seasonal wind wash up many drift objects on Japanese beach. Amount of litter and driftwood fall down from land area and through the river into the open sea. And this case is also observed at Seto Inland Sea in Japan. In Seto Inland Sea, it was 31 million people live in the watershed, and 21 Class A river flow into. In Seto Inland Sea, 31 million people live in this watershed, and 21 Class A river fall into sea through this area. And now, many people visit the sea or beach is the reason of plastic pollution. And many marine litter wash out from beach and settle on the sea bottom and can only remove by diving and tour net. So based on this case, standing stock and mass balance of marine litter need to be measured. In this study, they investigate Seto Inland Sea, and there is 440 kilometers from east to west and has 3 channels connect to the Pacific Ocean and Sea of Japan. And also use visual investigation of standing stock from May 24 to November 21 in 2006 at 261 beach at Seto Inland Sea. And in this method, they select 10 meters for each beach to visually investigate marine litter. And next, they will classify into level from 10 to 0. At the same time, they monitor it every month from 2 years from July 2006 to June 2008 at 4 seasons. At 4 seasons to obtain different factors from opening direction of beach. Overall, they compare the abundance of marine litter in different beach types. So standing stock is the amount of litter at each beach multiplied by opening direction factor and beach types. In this figure, show the mass balance of marine litters. W1 is inflow from the land, and W2 is generations in the sea. W3 is inflow from the open sea. P1 is remove of litter in the sea surface. P2 is removed on the beach, and P3 is removed from the sea bottom by tour net or diving. And S is settled on the sea bottom. F is outflow to the open sea. And standing stock M are drifting litters in the ocean and wash up litters on beach. So the mass balance of marine litters is M minus W minus F minus S and minus P. And W is total inflow. F is the outflow. S is the settle on the sea bottom. And P is the total remove. And use the record of remove from the Ashida River in Fukuyama to estimate the amount of input litter from rivers. Use the obtained rate of land-based litter to the sea-based litter and multiply by the amount of falling down litter. And author also collect 2,300 deposible lighters from Seto Inland Sea, and only 150 deposible lighters distribution location can be identified. So collect the percentage of deposible lighters from each site and estimate the amount of litter from the open sea. And use the actual amount of removed litter multiplied by the rate of man-made litter to estimate litter removed by sea surveys, which cleaned up by government. And marine litter on the sea bottom from the whole sea area was estimated to be 5,600 tons. And this finding was based on the average density of deposit litter on the sea bottom and area of whole Seto Inland Sea. And F could not directly measure, so it was calculated by total inflow W, remove P and S, and investigate 261 beaches surrounding the Seto Inland Sea, and it can show beach with index rate higher than 4 were distributed around the strait. And this figure shows the distribution of total volume of litters, plastic pipes of oyster farming, and styrofoam by the coastline, and rate of beach that oyster pipe and styrofoam wash up a lot on the beach. However, the percentage of oyster pipes and styrofoam to the total volume were only 14% and 2%. So small litter only have small impact on the total volume of litter, although they wash up in higher density on some beach. By visual investigation, the total standing stock M of marine litter in Seto Inland Sea was 3,400 tons. The total standing stock M of marine litters in the Seto Inland Sea was 300 and 400 tons, and the remove of the river was 600 tons. The inflow from land W1 was 3,000 tons. And the generation of litter in the sea W2 was 1,200 tons. Inflow of litter from the open sea W3 was 300 tons. So total inflow was 4,500 tons. And removed litter P was 1,400 tons. The deposit litter S was 700 tons. So total removed was 2,100 tons. And the outflow is 4,500 minus 2,100 equals 2,400 tons. Based on the mass balance models of marine litters in Seto Inland Sea and measure how to reduce marine litters abundance in the enclosed area. In this equation, if the remove effort increased up to 1.5 times, the standing stock M will only reduce to 87%. And if the standing stock M will be reduced to 50% of abundance, the remove effort need to increase up to 4.2 times. And if the remove effort is 0, the standing stock M will be reduced to 145% of abundance. So overall, a small increase of remove effort will not significantly reduce the standing stock, but stop to remove will significantly increase the standing stock. And in this case, if the inflow letter does not change, outflow to the open sea and on the sea bottom will not decrease to 0, even though the remove effort will increase more and more. And if remove effort increase to 4.2 times, the outflow will decrease only 50%. And this finding suggests that need to at least maintain the percent remove effort of litter. And now, most marine litter is not only dumped directly into the sea or rivers, but also washed out to the sea and widely distribution on land. So prohibit marine litter from individual sources will not significantly decrease the inflow. And based on mass balance model, a small increase to remove will not result a significant decrease in the standing stock, but stopping remove will lead to a significant increase. And beach rates higher than 4 are 17% of total study location, but they have 80% total amount litters on all study beach. So this finding suggests that removed marine litter at high density location would significantly decrease total marine litter density and abundance. And remove litter in high density location and continually remove could reduce the abundance and density of marine litter in in-coast sea area. And thanks for your listening.
Thank you.
Thank you, Chishan.
Thank you.
Yeah. Do you have any question to Chishan about this paper or her presentation? I have one simple question to Chishan. The authors regard the sea bottom debris as a kind in slide 5 in the mass balance model. Would you please show slide 5 about mass balance model? In this figure, the deposition on the sea bottom S is a kind of outflow from the Seto Inland Sea.
Yeah.
But deposited litter in the sea bottom is also kind of marine debris in Seto Inland Sea. Shall we consider it as an outflow? Because it remains in the sea. It does not disappear or go away from the inland, Seto Inland Sea. It is still in there. But how can we justify it as an outflow?
I think in this study, the author only considered the mass balance on the surface. So when the marine litters settled on the sea bottom, I think author think it was outflow in this study.
Yeah, thank you. But I think still we have to consider it as a standing stock because we have to manage it because deposited litter can affect sea bottom ecosystem or it can affect the kind of fishery resources or damage the marine ecosystem, even it is in the bottom of the sea. Okay, thank you.